All right, on the top, we can factor out an x. When I factor out an x, that's going to give me this expression. In the bottom, I can factor out a 3. And now I can factor the top farther into x minus 4, x plus 2. That x still stays on the outside. This 3 still stays on the outside, and it's x plus 3, x minus 3. After all that factoring, nothing cancels. So that means there are no holes. And then I want to look at all my options here. So x-intercepts. X-intercept means I make y equals 0. If I set the whole thing equals 0, the entire bottom is going to cancel out. And I'm going to be left with just the top. So this is going to give me x equals 0, x equals 4, and x equals -2. So I have 3 x-intercepts for this question. For my y-intercept, it's going to be 0 because an x-intercept is also at 0, right? So if it passes through 0, 0, it's got to be 0, 0 for the y. But same thing, if I plugged in 0, I'd have 0 divided by -27, which is 0. Vertical asymptote. Whatever's left in the bottom gets set equal to 0. So x equals -3. And x equals +3. There's 2. Horizontal asymptote. I look at the degrees. Degree in the top is 3, degree in the bottom is 2. If the degree in the top is higher than the degree in the bottom, there's not a there's not a horizontal asymptote. Domain, I have to leave out asymptotes for the vertical asymptotes, so positive and -3. Range, I'm not leaving anything out. So this is just all reals, or I could say -infinity to +infinity. Putting this on the graph. So 1, 2, 3, and 1, 2, 3, and then intercepts here, here, and -2, 0 here. So to figure out what this graph looks like, I would have to plug in some points to get the shapes of it. But basically, inside here, it's going to end up doing something like this. Over here, it's going to do something like that. And over here, there's going to be a shape like this. Which this you would not have to be able to do on your test without a calculator. Okay, you'd have to be able to tell me where the asymptotes are and where the intercepts are, but you wouldn't have to be able to come up with all of this on your own. Okay, then the last part, it says the reciprocal parent function is reflected. So reciprocal parent function is 1 over x. Reflected across the x-axis, that tells me there's a negative out front. Translated 5 units to the right tells me it's a -5, and 7 units down tells me it's a -7. Write an equation that could represent this new function and identify the asymptotes. So it could be a negative out in front for this part, 5 to the right, and 7 down. My vertical asymptote would be at x equals 5. My horizontal asymptote would be at y equals -7. Write a rational function with an x-intercept at -9, 0. So x-intercept means the top would give me -9 when I solve it. So if it gives me -9 when I solve it, it's going to be x plus 9 in the top. So I know it has x plus 9 in the top. A vertical asymptote at 3, so vertical asymptote at 3 means it's going to be x equals 3, so x minus 3 would have to equal 0. so that has to go in the bottom. Then it says a hole is located at 1, -5. So if I have a hole with an x value of 1, that means the factor of x minus 1 had to cancel out. So I'd have to have an x minus 1 in the top and the bottom. This could be my function based on the information they gave me. It says then identify the horizontal asymptote. So horizontal asymptote is going to depend on the degree. If I were to multiply this out in the top, I would get x squared plus 8x minus 9. In the bottom, I would get x squared minus 4x plus 3. The horizontal asymptote, the degrees are the same, so leading coefficient over leading coefficient is just going to give me a 1. Okay, again, this is a challenge question. It would not be something you have to be able to do, but definitely you should be able to do number 8.